All right, so for this given power series, we're trying to find the interval of convergence. So as I mentioned, you first label out your an and your an plus 1. So your an in this problem is going to be 3 to the n times x minus 2 to the n over n plus 2. This means that an plus 1 is going to be 3 to the n plus 1 x times x minus 2 to the power of n plus 1 over n plus 1 plus 2. Now, you could do your rewrites here if you want. You could have said that, okay, that first piece, 3 to the n plus 1, is really 3 times 3 to the n. The next one would have been x minus 2 times x minus 2 to the n. And then in your denominator, it's going to be n plus 3. The reason why I did the rewrite in such a way is because I know that when I have to compute the limit, I got to simplify. So I'd rather show you all the pieces. Okay. So you have the limit as n approaches infinity of an plus 1. So that was the 3 times 3 to the n times x minus 2 times x minus 2 to the n over n plus 3. Somebody probably has like 3 stars on GTA there. Divided by an, which is 3 to the n, x minus 2 to the n over n plus 2. Sorry, wait, was there any factorials? No, there was no factorials. All right, that's fine. Okay, so instead of dividing, we multiply by the reciprocal. So we have the limit as n approaches infinity of that whole long piece again. Just rewriting this, just a mouthful to say. N plus 3 times n plus 2 over 3 to the n, x minus 2 to the n. So now you should recognize what's going to be simplified. X minus 2 to the n's are gone. 3 n's are gone, but nothing else. Everything else will stay. So we have limit as n goes to infinity of 3 times x minus 2 times n plus 2, all divided by n plus 3. All right. Now remember, this limit says n is going to infinity here. So the variable x is irrelevant. You can actually pull out the absolute value of x minus 2 and just compute the limit. So you have absolute value of x minus 2 times the limit as n approaches infinity of 3 times n plus 2 over n plus 3. And now we can evaluate this. What would this limit go to? Careful.
Oh, yeah.
3. That's right, because you have 3n plus 6, technically speaking. So your powers are the same. Take the ratio of the coefficients. That's going to be 3. All right, so this piece is going to give you a 3. So you have 3 times the absolute value of x minus 2. All right, so to clean this up, 3 times the absolute value of x minus 2 now. That has to be, in order for it to converge, it must be less than 1. Now, in order for this to be less than 1, if you want to expand on this, you divide 3 on both sides, you get the absolute value of x minus 2 is now less than 1 over 3. But you can rewrite this where you remove the absolute value bars, right? Technically speaking, if you have the absolute value of x minus 2 is less than 1/3, then this statement implies, right, that negative 1/3 is less than x minus 2, which is less than positive 1/3. Now you got to get your x by itself. So if I add 2 to both sides, I'm just going to skip through this. I'll tell you what these are going to be. If you do 2 minus 1/3, that's like saying 6 over 3 minus 1/3. So that's 5/3. So we should get 5/3 is less than x, as this cancels out, less than 7/3. So far what we found out, if you look at this number line, let's say from 5/3 to 7/3, anything in the middle here, we know that we have convergence. Right, so basically what we figure out is that here in the middle between these two values, you have convergence. You now got to check the endpoints. Right, what about the endpoints? So what you got to do is plug in these endpoints back into their series and then figure it out. Okay, so we say when x is equal to 5/3, let's look back at our series. It was originally defined as the sum of n equals 0 to infinity of 3 to the n times x minus 2 to the n over n plus 2. We have n equals 0 of 3. Sorry, I had to go back. 3 to the n times x. Well, your x now is going to be 5/3. So you have 5/3 minus 2 to the n over n plus 2. You can simplify this, right? What's 5/3 minus 2? -1 over 3. So good things happen for us here. What we're going to get is n equals 0 to infinity of 3 to the n times -1 over 3 to the n power of n plus 2. Now, technically speaking, you have -1 to the n over 3n. So this entire numerator, this entire piece here, you could actually look at it as follows. You can say that you have 3 to the n times -1 to the n over 3 to the n. So what happens if you multiply by 3 to the n and then divide by 3 to the n? You'll have what? You'll have -1 to the n, right? So what you should recognize is that these 3 to the n's will cancel out, and you're just left with -1 to the n. So you have -1 to the n over n plus 2. Okay. Now, you want to test whether or not now this new series is going to converge or diverge, right? What series test do you think I could apply? Say louder. Alternating. That's right. For this one now, apply the alternating series test. So for the alternating series test, two things got to be true. That sequentially the terms are decreasing and that the limit has to go to 0. Right? I'm going to define, I can't use an because I used that earlier when I was solving this problem. So I'm just going to call it the sequence a new name. I'm going to call it bn. So I'm going to say let bn be equal to 1 over n plus 2. So now we check. If I take the limit as n approaches infinity of bn, we want to see if this is equal to 0. Well, let's see, our bn here is 1 over n plus 2. Is this equal to 0? Yeah, so that checks. Now we want to also check that sequentially the terms are decreasing. So that means that we also want to check that bn is greater or equal to bn plus 1. That means the next term, which is greater than or equal to the next term and any terms that comes after, right? So starting with n equals 0, if you use n equals 0, the first term would have been 1/2. The next term would have been when n is equal to 1. So you will get 1 over 1 plus 2, which is 1/3. And then your next term would be 1 um 1 over, let's see, your third term would be, no, your third term was when n is 2, so you get 1/4. So if you look at this inequality that I wrote out here on the bottom, is it valid that 1/2 is less than or equal to 1/3, less than or equal to 1/4? Is it decreasing? Yeah, it is decreasing. So by the alternating series test, I know that when x is equal to 5/3, the series will diverge, right? So by alternating series tests, when x is equal to 5/3, the given series, I'm not going to write out the actual series, but just say the given series will converge. So if you go back to that number line that I wrote out, I could shade in 5/3. I can definitely shade in 5/3. I can shade it in because now I know that it also converges there. The question now is what happens at the other endpoint, namely at 7/3. So now that's what I have to check, right? So I'm going to redo this all over again. When x is equal to 7/3, we're going to get, let's see, n equals 0 of 3 to the n of 7/3 minus 2 to the n divided by n plus 2. But what's 7/3 minus 2? 1/3. So you're going to get the series from n equals 0 to infinity of 3 to the n times 1 over 3 to the n over n plus 2. But what do you think is going to happen to the 3 to the n and 1 over 3 to the n? What do you think is going to happen to them? Yeah, they're going to cancel out, right? You're just going to be left with the 1, right? So all of this good stuff here in the numerator is going to cancel out. It's going to become a 1. So you'll have n equals 0 to 1 over n plus 2. Now, what do you think? Is this series going to converge or diverge? Why do you say diverge? It is going to diverge, but what can we do, like a comparison? Can we compare it to something? Yeah, we could compare it to 1 over n, right? So we're going to compare it to n equals 0 of 1 over n. We know that this is a divergent p series. It's the harmonic, where p is equal to 1, right? The exponent. And 1 is definitely less than or equal to itself. So if you do a limit comparison now and the limit exists, then you know that it definitely they both diverge, right? So compute the limit. You can't use the divergent test for this one, Preston, because actually if you compute the divergence test, you get 0, which is no good. You want to get something that's a non-zero. All right, so we would have done, sorry, I don't need absolute values. We'd have had 1 over n plus 2, all divided by 1 over n. But this is equal to the limit as n approaches infinity of 1 over n plus 2 times n over 1. So this is n over n plus 2, which is equal to 1, which is definitely bigger than 0. So by the limit comparison test, when x was equal to 7/3, both series will diverge. Now, since at x equals 7/3 you have divergence, then when I had that circle that I drew, the number line that I drew, right? We included 5/3, but we're not including 7/3. So when you write out your interval of convergence, it's gonna be like a half open, half closed interval. That's gonna be starting with a square bracket, 5/3, ending at 7/3, but with a closed parentheses. And that is your solution.